Hello all, this is Niranj here and welcome to the video. Today we are going to see some important topics on Fleming's right hand rule and the topic which you might be very familiar with, that is the electric generator. Okay, so basically what do you mean by an electric generator? What's the purpose of an electric generator? You might wonder how the electricity is being supplied to your homes. Well, we have an answer here. Yeah, we can look into the topic. Okay, first of all, what do you mean by Fleming's right-hand rule? Basically, a mnemonic device to determine direction of induced current in a conductor moving through a magnetic field. Okay, Fleming's right-hand rule. We can place our fingers like this to demonstrate the Fleming's right-hand rule, and it is basically what device to determine the direction of induced current in a conductor moving through a magnetic field. Clear? Now we can see where this how this Fleming's right hand rule is being applied. Okay, Fleming's right hand rule, we have three fingers, that is thumb finger and forefinger as well as middle finger. So what's the purpose of this three fingers? We can show our thumb finger to represent the direction of motion, and we can show our forefinger to represent the direction of magnetic field, whereas our middle finger represents the direction of induced current. So the topic must be very clear, that is Fleming's right hand rule is just a device to represent the flow of current in a magnetic field, the direction of in which the current flows in a magnetic field. Okay, here are the three tools which we use, that is our thumb finger and our forefinger as well as our middle finger. Okay, then coming to the generator, how we can apply this right hand rule in generator. So basically, you might have seen generators in the home and as well as in many functions. So what's the purpose of the generator? They produce and they generate LP, right? So where do we use this real world application of this Fleming's right hand rule? We can use this in power plants in as a car alternatives and wind turbines, hydroelectric plants as well as bicycle dynamo. Now, moving on to the next thing, the what do you mean by an electric generator or an AC generator? A machine that converts mechanical energy into electrical energy using electromagnetic induction. The principle we are using in electric generator is electromagnetic induction. Electromagnetic induction is the basic principle we use to demonstrate or to understand the concept of electric generator or the working principle of an electric generator. Okay, it uses the mechanical energy will be converted into electrical energy. Yeah, fine. Now, so the Faraday's laws of electromagnetic induction. Based on this Faraday's law of electromagnetic induction, moving conductor in a magnetic field generates EMF. Okay, generates EMF. The changing magnetic flux induces electric current, and as you can see, the faster the flux changes, there will be greater change in the electromagnetic induction. Clear? So what are the main components of this electric generator? We have a rotor here, rotor, then we have magnetic rotor which cuts the magnetic flux lines, and we have stator, that is a magnet, and we have armature. So basically there are three major components which are rotor, stator and an armature. Rotor is nothing but it is a rotating part. Here we have the rotating part here, and the rotating part will be placed in between the magnets. So magnet is a stationary part, it will not be moving, so we call that as a stator. And the magnets provides constant field, and this rotating coil or the rotor which they cut the magnetic flux lines. So what happens is when this magnetic flux lines are being interrupted continuously, they produce EMF or they induce EMF. So that will be converted into electrical energy. Clear? Okay. Now, what are the additional components we have here are the slip rings, the prime mover, the voltage regulator, and the control panel. The slip rings and the brushes, they transfer the current from the rotor, while the prime mover provides mechanical energy, and the voltage regulator maintains consistent output voltage, whereas the control panel monitors and controls operations. So these are the major components of an electric motor, which includes stator, rotor, and the armature. And also they include slip rings and brushes, the prime mover, and voltage regulator. The concept of electric motor is very simple. That is, we are converting an mechanical energy. Okay. So for better understanding, here we have an animation. Okay, basically we have a permanent magnet, that is a stator part, the stationary part, and uh, it will be we are having an armature. Okay, here we have yellow painted and as well as silver painted armature. That is to understand the flow of current. Okay, that is for you to distinguish the flow of current. So we are having two permanent magnets, that is we are having north pole as well as south pole. So when we rotate this armature, that is the magnetic flux lines are being interrupted. So the rotation can be through any method. We have seen the rotation through many things. Okay, so now this armature are being connected to slip rings. We are connecting the armature to slip rings because through slip rings we can connect that to a power source. Okay, to through slip rings and the carbon brushes. We have two carbon brushes here, and the slip rings and this carbon brushes connect the armature, and we are connecting both of them or joining to a galvanometer. So basically, why we are joining to a galvanometer, or the purpose of joining this to a galvanometer is to understand whether the current flows through it. Okay, that's the purpose of connecting that with a galvanometer. See, magnetic flux is a measure of the total magnetic field which passes through a surface. Okay, the flux is the total magnetic field which passes through a surface, and we have north and south poles here, and the magnetic uh, field lines are being interrupted while this armature rotates. What happens is that basically the armature rotates and the magnetic flux lines are being interrupted in this magnetic field. So while doing so, it generates an EMF, or electromotive force we call it. EMF is nothing but electromotive force is being induced in this, and they are being converted to the electrical energy. And this conversion can be understood by pairing that with a galvanometer. So basically, how do this rotate, or how does this armature rotate? We can do the rotation in many ways. For example, earlier we have seen that connecting a fan through this armature. So in like hydroelectric power plants or the dams or reservoirs, we can connect this to a turbine, and what happens is when water falls through this turbine, this armature rotates, and this armature is placed in between two magnetic field, that is north pole and south pole, a permanent magnetic field or a stator part. And we are placing this armature in a stator part, and this armature keeps rotating or keeps spinning, and the electric current or electric power is produced. And this production can be understood by using Fleming's right hand rule. That is the thing we have seen earlier. Okay, the motion, the field, as well as the production of current can be understood clearly by using the Fleming's right hand rule. So there are two types of generator. We have AC generators as well as DC generator. So what do you mean by AC generator is it produces alternating current. Basically, it is in the name itself. That is, AC generator produces alternating current, whereas the DC generator produces direct current. Okay, and we are using this AC generators in power stations, and the frequency ranges between 50 to 60 hertz. Whereas we are using this generators, DC generators, they use split ring commutator. Okay, we have the split commutator, and in DC generators they have split ring commutator. The ring will not be constant; they will be broken in between. So that's the difference. And what are the real world application of this electric generator is they are being used in hydroelectric power plant. That is, the water flows, and it helps the turbine to rotate, and they produce electromagnetic induction, and which gives you the electric power. The science or the physics is simple. That is, the water flows and it falls to a turbine, and it makes the turbine to rotate or the turbine to spin. So when the turbine spins, we can create an electromagnetic induction, because the turbine spins in between the permanent magnetic fields, or there will be the change in the magnetic flux. the magnetic flux will be changing when the armature keeps rotating. So that produces electric power. So that's the basic physics behind it. And the factors affecting this generator output are uh, basically the rotation of this armature and the number of turns or the number of coils used in this magnets. These are the basic things or the factors that affects the power generation or the amount of power that are being generated through magnets. Okay, that's all about AC generator, and see you in the next video. Thank you. Bye bye.